For today's class, please go ahead and open the very last model that we worked on in previous session. So that's when parts A and parts B arrived. They were processed in prep for part A and part B, and then they went to the sealer. Some of them went to the rework and some of them did not. And then at the end of the day, they left the system either as a normal part that passed the inspection, or a part that was scrapped, or the part that was salvaged and finally left the system. Okay, so I want you guys to please open this model, and then for today's class, create a folder for week 7. Since we are in week 7, please create a folder for week 7 and then save this model as a new model in the folder for week 7. And at the end of the name, please add routing. So the concept that we want to talk about today is related to the transfer time. So right now, in every model that we have done so far, we assume that when a part is done in one operations, let's say here, when we are done processing part A in this operation, it immediately, and if the sealer process is idle, the part immediately goes to the sealer operation and gets processed. And the same for this. So when the part is done in the sealer process, when we inspect and we see, oh, the part needs rework, it immediately goes from the sealer to the rework and so forth. However, this is not the case in the real world problems or the real world situations. We always have some transfer time, some some transfer time between the operations. So when the part is done in this machine, when the part is processed in this machine, then it will take some time before the part is available to get processed on the sealer machine. So, and this is really the case because, for example, these machines have distance, right, from each other. And we may have one worker that is in charge of picking part on machine A here and then taking them to the sealer machine. We may have some forklift that come to get the parts from one machine and take them to the next machine. We may have some conveyor between the machines. So we are done on this machine, we put the part on the conveyor, and then it takes time for the parts to finally get to the sealer machine and get processed. So it's very natural for the models that we are going to develop to want to account for transfer time between the machines or between the operations. So here in this model, in this session, we are going to learn how potentially we can consider transfer times in the models. So the two modules that we are going to learn are coming from Advanced Transfer Panel, and they are Station module and the Route module. So first, if you guys do not have the Advanced Transfer template, can you tell me how you can bring it to your window, to your simulation window? Go to File.
And Template panel.
Template panel.
Attach.
And then you pick the Advanced Transfer. So, okay. So, yeah. So make sure to go to the file, attach the Advanced Transfer template so that you guys have this. So we are going, the first model, we are going to learn Station and the Route module. So, okay, so what we want to do is to make sure there is 2 minutes transfer time between all these machines, and also between the arrival of entities wherever they arrive to, between the arrival point and the first operation, which is the processing part A and processing part B machines. We want to make sure also there's 2 minutes transfer time between those 2 points as well. So when parts arrive, they arrive to a specific to physical location in the system, and then they go to the machines for processing part A and to the machine for processing part B. Okay. So we want to make sure there is 2 minutes constant, fixed 2 minutes transfer time between all these machines that are in this system. So the way that we have to do is, or the way that Arena works is that before we transfer the parts between these operations, we have to tell the simulation that these are actually my physical locations. In the arena right now, this is just one operation, this is just one operation, this is just one operation. Arena does not look at them as like physical places when the entities go to, and there is time for us to get to those points and so forth. So first, then we have to tell Arena somehow that when the parts arrive, actually there is some physical locations related to these arrival points. When the parts go to get processed on these machines, there is some physical locations associated to these points. And then there is 2 minutes transfer time between this physical location and this physical location. We also should do the same. We have to tell Arena that there is a physical location associated with this processing time, with the sealer process. And then there is 2 minutes for going from this physical location to the sealer physical location, 2 minutes from going from this physical location to the sealer physical location, okay? So to be able to do that, we are going to use the module station. So basically we are going to assign one station to each one of these operations that happen, and from there is a transfer time to the other processes. So we are going to assign a station module to each one of them. To be able to do that, first let's delete this connection. Delete this connection. Delete this connection. Okay, so we disconnected the connection between the sign module and process part A and process part B. And then I want you guys to pick these 4 module. If you just do this, they will be picked, okay? And then drag them to the left. I want to just open some space. So drag them to the left and the reason is new modules between these two, and I just want to make sure we have enough space to put those modules, okay? So now the first thing that we want to do is to tell the simulation that when the parts arrive to the system, there is actually a physical location associated with this arrival. To be able to do that, I'm going to use the station module. So drag the station module and just put it here. Okay, so let's see what happens in the station module. So in the station module, I say that the name of this station is arrival stations. Part A, arrival station, okay? And I'm going to keep it as arrival. And I'm going to keep it as station. So later we will have scenarios when I will tell you what does the set means and so forth. So for now, we are going to keep this as a station. And then for the name of the station, just copy the same thing and put it here. Okay. So the difference between these two name and station name is that station name is the name that is used in the logic of the simulation behind the scene, in the codes and everything. This station name is the name that is going to be used. The name that we put on the top is the name that we are going to show here in the model. If for whatever reason you want to show a long name that just tells very clearly what does this station belong to and so forth, you can write a long name here. However, if you want the name that is used in the logic of your model behind the scene to be a short name, you can write a short name here. But I recommend usually that just put the same name for both name and station name, and make sure the name is not too long. Just put a clear name for both two boxes. Okay, and then do not do anything for the other two boxes that are empty, and just leave them as empty. Later we'll explain what do they mean. And press OK. Make sure to save your models as we go forward. Okay. So now we are going to also connect the sign module to this station. So that tells the simulation that when parts arrive to the system, and as soon as we assign them the sealer time and the arrive time, they actually are in this physical location. So nothing has happened here, so, right? No processing time, nothing. The entities just have arrived to the system, and we have right away given them two tags. And this is where these entities basically are located physically. This is where they are in the system. When we connect them to these two modules, that it shows that when the entities come to the system and go through these two first modules, then they are here. That's where they are located. The next thing that I want to tell the simulation is that when the entities get to the arrival station, then they want to go to the station that is related to processing part A. So I'm going to put another, so let's put another station here. And so I'm going to pick this station and I'm going to bring it here. And this is going to be processing part A station. Okay, so the type is a station as well. And for the station name, again, I'm going to copy and paste the name that I gave to this station. Okay, so this is processing part A station. Just making sure. Okay, and again, don't put anything on the last two boxes, and just and make sure the report statics is checked so that the simulation can calculate things for us related to the transfer times and so forth, and just press OK. And again, make sure that you guys connect these stations to processing part A, because that shows that when the parts basically get to this station, that's when they are going to get processed on this operation. Make sure to save. Everyone is good so far? Everyone is with me?
Yes, Professor.
Okay. So now, okay, I assigned a physical location to the arrival, a physical location to where I'm going to process part A. What I have to tell the simulation right now is that it's going to take 2 minutes to go from the arrival physical location to processing part A physical location. And to be able to do that, I'm going to use the module route. So drag module route and put it here. Okay. So this module is, so basically here, I'm going to route the entity from the arrival station to the prep area for part A. So let's say I'm going to call this route to prep A station. Okay. And how long this routing is going to take is going to take 2 minutes. So in that scenario, so I'm going to just type as, and then change the unit to minutes. Okay, so the transfer time in this model is constant 2 minutes. So I'm not going to put any distribution, anything, it's just fixed 2 minutes. If the transfer time is not constant, for example, I tell you the transfer time has exponential distribution with average 2 minutes, then you can pick the right distribution here, if it's exponential, if it's normal, triangular, uniform, or anything, and then you can specify the parameters of the model. So I may tell you that the arrival time is actually normal with average 2 minutes and standard deviation of 1 minute. Okay, so specify that for the transfer time. If it's distribution, no worries, just put the distribution for the transfer time. In this scenario, it's fixed and it's 2 minutes, so all we have to do is to put number 2. Make sure to pick the right unit of time for your transfer time. I have seen that you guys forget and then leave it at hours or so, and then it just changes the whole things in your model. And one more thing is that like any other box in the that we have in the simulation in arena that we have learned so far. As long as you can type in it, as long as you can specify the distributions, you can always right click in this box and pick build expression. And if, for example, you want to specify more complex expressions for transfer time, you can do that as well. Okay. So the transfer time is 2 minutes. So then it asks you, what is the destination type? So the destination type is going to be an station. So we are going to go from one station to another station. And what is the station name? So the station name, right now, both the stations that we have identified are listed here. So we are going to go to processing part A station. Okay. If you have not defined these stations beforehand, you can type the name of the station, and that station will be created for you automatically. Later, when you put this station here, when you put the module here, you can just pick the same name that you have identified here. But that's a little confusing. So I always recommend you guys that create the stations related to this operation. And then when you want to put the route module, you know exactly from which station to which station you want to go to. Okay, so this is the route to prep A station. It's going to take exactly 2 minutes to do this transfer. And the name of the destination station is going to be the one that we're going to specify at the bottom. Okay, so press OK. And then one last thing that I need to do is that for this part to be done is that I have to also tell the simulation that this routing belongs to this station, meaning that when the parts get to this physical station at the start, the entities are generated and they are at this physical location, then you have to follow this route module, meaning take 2 minutes time, 2 minutes to transfer the part to this other machine or to this other physical location for this machine. Okay, we do not need to connect route to this physical station. The simulation will know automatically that when the route is followed, when the route module is executed, we are going to go from this station, which is connected to this destination station. So simulation will automatically take care of that. So make sure you do not connect the route module to processing part A module. Make sure to save, guys, as we go forward. And we are going to do the same for part B arrivals. Again, for part B, when they come to the system, there is 2 minutes before they are transferred. There are 2 minutes of transfer time to the prep B machine. So tell me how we are going to do that. What is the first modules that I have to bring here?
We need to bring a station for part B arrival.
Exactly. Make sure you guys do that as well in parallel with me. And for station name, just copy and paste. What is next?
We need another station right before processing.
So we need to tell the simulation that this station belongs to these operations. So belongs to this arrival. The arrival happens here. So that's the physical location that the entities are in. And we also need to tell the simulation that this physical location belongs to this processing. And what is the next thing? To bring a route module so that I can tell the simulation that it takes 2 minutes to go from this physical location to this physical location. So click on the route module. This is route to prep B station. How long it's going to take? It's going to take fixed 2 minutes. And what is the station that we are going to go to? It's processing part B station. And make sure to press OK. What is left here?
We need to connect Part B arrival station to route, or route to Prep B station.
Exactly. We need to connect part B arrival station physical location to the route so that simulation knows that when the entities get here, then we have to execute the route module and transfer them for 2 minutes. Behind the scene in the simulation, this is just another delay. Remember here when the parts go through the processing, we do cease delay release. Just behind the scene, the entity is delayed in this part, in this operation for whatever distribution amount of time we have specified here. So it's just a delay that is placed on that entity behind the scene. So that transfer time is basically just another delay that is put on the entity behind the scene so that we can mimic the concept of transfer time. Again, make sure you don't need that to connect the route module to the station module here. Make sure to save, guys. I'm going just to pick these and just move them a little to the left for the sake of just creating space. So now the part is done processing here. Where do I want to go next? The part wants to go to the sealer machine, right?
Professor, just to ask a quick question. So for every time that we need to transfer for doing the advanced transfer like this with route and station, we're essentially going to need 3 modules, like a departing station, the route, and then the receiving station, essentially, for every process.
Exactly. We need, for every 2 places that we want the part to go from place A to place B, we need 2 stations to represent place A and place B. And then we need 1 routing to capture the transfer time between these 2 places. Okay. So now we want the parts to go to the sealer operation. And obviously there's 2 minutes for transferring the parts between the Prep A machine and Prep B machines and the sealer operation. Can you, based on what we learned so far, can you just tell me what you think we have to do next? Like, how should I change this part?
So we'll need to get rid of the connections between all 3 of those processes.
We need to get rid of the connections. And I'm going to move the sealer module just a little to the right so that we have enough space. Then, remember in the model, this represents this physical location. But do I have any physical representation for the sealer machine?
To get a station for the sealer and just put 2 routes.
Exactly. So we'll talk about that in a second. But just first, we have to put a physical representation for the sealer process. So I'm going to bring a station and I'm going to put that for the sealer operation. So I'm going to call it sealer station. Okay, so don't change anything else. So this is sealer station. So, and I'm going to make sure it's connected to the sealer machine so that the simulation knows when the part gets to this physical location, this is the operation. This is right away the operation that is going to be done. Okay, so we put the physical location for the sealer and we connected it to the sealer operation. And what is next?
Create stations for both processing part A and processing part B.
We already have the stations.
Like departing.
We don't need the departing station. So this station, these two stations that we put here represent this operation. Okay, so the part has arrived here so far. So let's look at this. So the part arrived here. Then they got transferred to this physical station, and from there they got processed. Right there, they got processed at this physical station. So now, after they're done with the processing, what do we want to do? We want to pick them up and take them to the sealer station, right? So the part is done processing at this machine. I don't need another station. All I need to do is to put a route module so that when I'm done with the processing, the entity goes through the route module and then get to the sealer station. Okay, so this is just here for us to make sure the entity is delivered to this processing, and it's just taking 2 minutes, and that's all. And then right now we are done with the processing, so all we have to do is to send the entity to the destination stations, which is the sealer station. So what I'm going to put here, instead of just putting 2 route modules, so repeating this, I'm going to say, we can put just 1 route module. So then we can connect both these processes to this route. So what I'm going to say here is that this is route to sealer station. And this this transfer time is going to take 2 minutes. And the destination station name is sealer station. Okay. So this new route module that I put here, this new route module, I'm going to name it as route to sealer station. This transfer time is going to take 2 minutes, and the destination station name is the sealer station. So we are going to press OK. Okay. So what does this mean? That means, okay, the entity got here to this physical location. It got processed right away, and then it's going to be transferred to the next physical location. When I put this route here and I connect it to the processing time, it means after the processing times are done, then the entities go through this route module, and it's just going to take 2 minutes to do this transfer to the next station. We could put 2 different route modules, but it's unnecessary. We can just put 1 route module. Whenever each one of these entities are done, they are going to go through these route modules, and then they are going to get transferred to this physical station. Does that make sense?
Listen, I have a quick question. I'm wondering, whether Part A arrival station is really necessary, because I feel like the route module only cares about the destination. So can we actually remove the arrival stations?
No, we need to, we specify that because we need to tell the entities this is where we are. Right now, we know where the entities are and so forth, but we need to tell the simulation that where we are right now.
Oh, okay.
Where we are going to go next.
Thank you.
Sure. Make sure to save, guys, as we proceed. Christian, does that make sense?
Yeah, I suppose it's just mildly confusing what Yihang just said. all right, in agreement with what he just said, because I was thinking that we were needing essentially three modules: a station, like the arrival station, the route, and then the processing part before it goes to the processing part A and part B. I'm just a little confused as to why we wouldn't also need a station after processing part A and processing part B before it goes to the route and then the sealer station.
So you were confused why we do not need
Another station after processing part A and part B.
So because
before it goes to the route.
Basically, it's so the entity. So basically, what we want to do is just to make sure the entity gets here. Okay, and here also some of these stations are for doing the animation. So for the animations of the model to go through. So that's why one of these stations are there so that the animation goes through. We can apply the animation on the model as well. But generally, usually in the if we want to send an entity from one point to another, we always have to represent that point with a station and the physical location so that the transfer time can happen. So we put the stations here so that we can transfer the entities to this location. We put the station here so that we can transfer the entities to this location as well. We can try later with removing these two stations. I believe they are needed so that we know the entities, where the entity is initially in the system. And then it goes through the process.
So would it be safe to say then it's just necessary that each process from start to finish, including arrival, each process needs just one station?
Yeah, so basically, as I said in the start, is that stations just give a physical representation to the processes. It's not that one before and one we need one after. The stations are there so that the simulation knows these are like places, and we need when we are using the route module, the route understand going from wherever we are right now to the station location. I cannot say route to the sealer process. I have to send by the route to this station and then connect that station to another activity which is represented by that station.
Okay, so for like the sealer process, we have a sealer station with that process already. So if we wanted to go from the sealer process to sealer inspection, we don't need to create another sealer station. We can just go straight from that, do the route, and then to the sealer inspection station for it.
Exactly.
Next.
So basically, just use the first of all for the sealer inspection. This is not process, right? This is just a decision module that we put here. All the sealer process and inspection happens here, right? So this is just a decision module to help us know that after the sealer guy is done with the sealer process and all the inspection, this percent goes here, this percentage go here, right? So this sealer inspection really does not need a station at all. It's not a process. It's not a physical location in the model that I want to send the entity to and calculate the 2 minutes transfer time. All I care is that the entity goes to the sealer process, and over there, the sealing operation and the inspection, all of that happens. And then from there, I go to the rework. If the part fails the inspection and so forth, then I go to the rework. When the rework is done, that is a physical location. So I definitely want to assign a station to this. But also in terms of the logic of the model, just see the logic here. So this, when the entities arrive to the part A prep, we need to send them to a station, and so that the simulation knows where they are right now. And then they go get the operation done. And right now, after they're done with the operation, they are ready to be transferred to the next operation. So that's where I put the route module, because they are ready to be transferred. And then when they are transferred, they have to be transferred to a station. Then they get to this station, and which represents the sealer operation. So just follow the logic.
Okay.
I did a quick experiment by deleting the part A arrival station and part B arrival station. The simulation seems to still run with the same results.
Okay, yeah, so these some of these stations are here for the sake of performing the animations later in the model, so that when we perform the animation, we can show exactly where the entities come to and where they go from here. So at this point, we can put the route operation so that they can go from the arrival to this destination.
Yeah, that makes sense. Thanks.
Thanks, David, for checking. And okay, where we are? Okay, we are in sealer station. Route to the sealer, and we are in the sealer station, and we specified the 2 minutes route time. And then, okay, so when the sealer operation is done and when the inspection is done, we know some of the entities need to go through the rework, and some of the entities are going to leave the system. Even if the entities leave the system, we still want to make sure we capture the 2 minutes processing time. Okay. So first, so we captured the 2 minutes transfer time. So first, let's take care of the rework part. So I'm going to pick this part. Just move all of them a little to the right. And make sure to disconnect. And then here, so if the part after we are done at the sealer operation and inspection, the part may go for the rework operation, we need to assign a physical place to the rework operation. So that's where I'm going to bring station module for the rework. Okay. So make sure to connect the rework station to the rework process so that we know this physical location represents this process. And also here, when the part is done at the inspection and we need to perform the rework operation. So we are at the sealer, we have done the inspection and sealer and inspection operations, and we have checked the parts, it needs the rework, okay? And this is the physical location that represents the rework. And tell me, how should I capture the 2 minutes transfer time from the sealer machine to the rework machine?
You just need one route module.
And where am I going to connect it to?
You'll put it right after the sealer inspection for true.
Okay. So this routing is going to be related to this sealer inspection operation. So here, this is route to rework. It's going to be 2 minutes. It's going to be in minutes. And where is it going to go to? To rework station. So rework, route to rework, 2 minutes. The station, the name of the destination station is route, it's rework station. Okay. So make sure to connect this route to the true part of this decision module, meaning that when the entity got to the sealer operation, we process it, we perform the inspection and so forth. If the part does not pass the inspection, then the part goes through the transfer operation to get to the destination station, which is the rework station. Okay, so make sure to save as we go forward. And how about for this part? So the parts that pass the inspection are the parts that are going to just get shipped and go out, okay? However, we want also to capture 2 minutes that goes from the inspection to the shipping part. Can you tell me how we do that? So there is a 2 minutes. Go ahead.
I was just going to say, would we put the rework, or I'm sorry, would we put the shipping items station after the record shipped entities module?
Okay, so the first.
And the route would go right directly after the sealer inspection for the shipped entities.
So we need to. So basically, what happens is that first of all, as you said correctly, we need to specify one station to the end of the process here, right? The part is going to go out, and I'm going to put a route module to say I'm going to transfer this part for 2 minutes to a physical location, right? So I need a physical location here for sure. Okay, so then the question that Christian asked was that, like, or is thinking about is that, should I put this station before the record module or after the record module? Okay, so since the route is taking me to right away to the destination, so we can put the route to the physical location here. So we say that, let me just delete this. So I'm going to put the physical location here. So this represents the shipped port station. Okay, so now when I create this ship part station, I want to say, okay, it's related to this part of the process. So when you get to this station, make sure to record everything and finally let the part go. Okay, so let me connect this to this. So when the part gets to this station, then we are just going to report the statistics and let it go. Okay. So then I also need to tell the simulation that after the parts is done with the sealer and inspection operation, it takes 2 minutes for the parts to get finally to the shipping physical location and finally leave the system. So I'm going to put a route module here and connect the route module to this. Oops. And here is route to ship parts. It's going to take 2 minutes. And the destination is shipped part station. Okay, so what happens here? So when if the part passes the inspection, we are right now at the sealer station, right? So the part is, we have done the sealer operation, we have inspected the part, and the part is passing the inspection operation. So now I have to tell the simulation that it's going to take 2 minutes for this part to go to the basically the last step, which is when the part is going to be shipped, right? So that's where I'm going to put this 2 minutes route time here to say that it takes 2 minutes to go to the shipping destination. And then, however, I again need to represent this destination by one station so that the simulation knows where this entity is going to go to. So I assign a station here, and I put that station before the record module. Because if I put that station right after the record module, and then I go from the routing to the station after the record module, that's where the entity is going to go, and then right there is going to basically get disposed and leave the system. Okay, so if I want the entity that to get to the destination, to the shipping destination, and however before that I want these recordings to happen, then I have to put the station module just before this. Remember, these stations and things are basically places for the simulation to know where the entity is going to go to and how long does it take for the simulation to go from this location to this other location. So that's what the route module is specifying for us. So if I say go in the route module, if I say it takes 2 minutes to go to the station, to the shipping parts station, and then I put the station here, that's where the entity is going to go to. And then the next operation that is going to perform is the dispose module. However, if I want the entity to record a couple of things before it really leaves the system, I have to put it before the record module. And also pay attention that the record operation, the record module doesn't have any time. So it's perfectly fine if we perform a bunch of recordings and stats and things like that before the, after the part gets to the shipping operation and before it gets exactly disposed, because no time is spent in any one of these two modules. So the places that we put these order of these stations and order of these modules and order of the route module is basically the way that you think about them. The part gets to this station, goes through these operations, and then is transferred to the next operation, and this is where the next operation is. The part gets to the sealer operation, goes through all these actions, then it's transferred to the shipping places. That's where it's going to go to. However, before the part leaves the system, I want to record a bunch of things. So I'm going to do that after the parts get to the shipping place. I'm going to record all these things and then send the part out. Does that answer your question, Christian?
Yes, it does. Thank you.
Make sure to save your model, guys, as we go forward. So now, let's assume the part has gotten to the rework station. So I have performed the rework that is going to take 45 minutes exponentially distributed. From there, I'm going to go through the, after I perform the rework, then some percentage of the part will be scrapped, some percentage of the part will be salvaged and will leave the system. However, even if the part is scrapped, it takes 2 minutes to send the part from the rework station to the scrap station. And it takes two minutes to send the part from rework station to the salvage part, shipping part, shipping station. So how should I capture that 2 minutes transfer time between the rework operation and to the disposal of the scrap and to the disposal of the salvage part?
So wouldn't we, just like the previous decide module, we would just put routes modules right after the result for true or false, and then put a station right before the record for each of the directions.
Okay. So first, I'm going to move this a little to the right to create space. So what I need to tell the simulation, first, I have to tell the simulation there is a physical location that represents where these parts are being disposed, either as a scrap or as a salvage part, how these parts leave the system. So I need a physical representation for these two. So I'm going to bring a station module for the first one. That's going to be station. And I'm going to connect it to the record module so that I know this physical location represents this part of the simulation. And I'm going to bring another station module for salvage parts station. Okay, so now I told the simulation that this physical basically location represents the end of the simulation when the parts are going to be disposed either as a scrap or as a salvage part. Then I need to tell the simulation, it takes, after you are done with the rework, it takes 2 minutes to go from the rework to either the scrap part, to the scrap disposed part, or to the salvage disposed part. So then I have to put a route for this part. So here, this 2 minutes is basically the route from the rework to scrap part station. This is going to take 2 minutes. And the destination station name is scrap part station. And I don't need to connect route to the next station. The simulation will automatically know what is the destination station, so what is the entity needs to go to. And then the next route, the next module that I'm going to put here is a route for this part. If the part passes the, after the rework, some part will be salvaged, some part will be scrapped, some part will be salvaged. And this is the route to salvage part stations, route to salvage part stations, and that's another 2 minutes. And the destination station is salvage part. Okay, so when the entity get to the rework station physical location, we perform the rework operation. We search to see how the rework has been done. If the entity is not good after the rework and is going to be scrap, we are going to take 2 minutes to transfer part to the scrap part physical location for disposal. So I put the station here, and as soon as the entity gets here, right before the entity leaves, I need to record a bunch of statistics, so I do that. And the same for the parts that finish the rework and they are good, they have been salvaged. I'm going to take 2 minutes to send them to the physical location for shipping of the salvage parts. And right there, when the entity gets there, they can be disposed and leave the system right away. However, before that, I'm going to record some statistics associated with that part and then let them to get disposed or leave the system. Make sure to save. Okay. So basically the stations are helping you to give a physical representation to these operations, and the simulation need to have them so that the simulation knows where to send the entities using the route module. The route module, on the other hand, helps you to specify the transfer time and If the transfer time is fixed or distribution or expression, you can specify that. You can specify the unit of the transfer time, and then you can specify the destination station as well that this entity has to go to. And then once the entity gets to the destination station, it just goes through the rest of the process like normal. Okay, so this route module basically is a way for the simulation so that behind the scene, it can impose some delay to this module, to this entity. So it can perform some 2 minutes delay on this entity, which behind the scene is going to be calculated, is going to be considered as transfer time. So make sure to save, and then we are going to run the model. And like before, we are going to run it for 10 days, and each day is 16 hours. So press 1. And you can put it in the fast forward. So if I go to the entity, you see here I have value added time. Those are the processing times. Non-value added time, I don't have anything because we didn't assign anything as non-value added. I have the waiting times. Those are the waiting times in the queues that simulation automatically calculates for us. And then here I have the transfer time. We didn't have the transfer time in previous models. Right now I use the route module to assign transfer time. So I have transfer time between these between the operations. So now the transfer time also has been calculated for us. And then I have the total, which is the sum of all those times that we have on the top: value added time, wait time, transfer time, and so forth. And you can see the rest of the statistics as before. Again, we see the user specify the statistics because we assigned 2 counters and 2 tallies in the previous model. So we can specify, we can see all of those as well. So basically the thing that was added to us, to the model this time, is the transfer time that was added here. So as you can see, the minimum value for the transfer time is 6 minutes. That means, so the entities come to the system. There's 2 minutes till they get to the first operation. That's 2 minutes. All of the entities go through that. And then there is another 2 minutes to get to the sealer operation. That's 4 minutes. And then there is another 2 minutes to get to the rework. If they don't pass the inspection, they go to the rework. That's another 2 minutes. That's 6 minutes. And then at the end also there is 2 minutes to leave the system, either as a scrap part or as a salvage part. So that becomes total 8 minutes. Okay. So, however, some of the entities, when they come to the sealer operation and they get inspected, they don't need any reward. So they just take 2 minutes to leave the system as a perfect part that we are going to ship. So for those entities, previously we had 4 minutes, and now we are going to add another 2 minutes, it's 6 minutes. And that's why if we go back and see the results here, for the transfer time, you see the minimum time for some of the entities is 6 minutes. Those are the parts that didn't fail the inspection and were shipped right away. And so for some parts, the transfer time is 8 minutes. That's the transfer time for the parts that failed the inspection and went through the rework and so forth. Okay, guys, what I want you guys to do next is to build a model on your own. And this is the model that we are going to work on. Okay, so part arrived with average inter-arrival time of 1.1 minute, exponentially distributed. Upon arrival, they are unwrapped by one of the 4 identical workers. One single queue fits all the workers. The unwrapping time is triangular with mean 2, mode 3, and max 4. The unwrapped parts then get separated based on their type. 30% of the parts are type A and the rest are type B. The type A parts get processed with a processing time which is triangular 2, 3, 4, and type B parts then get processed with a different processing time. And there are 2 people that process part A and 1 people that process part B. When the parts are done and they are processed, they leave the system. So we want to know the cycle time associated with these 2 part types, type A and type B. And also one other thing is that there is on average 1 minute transfer time between the machines, exponentially distributed. And this is not just between the machines, but also between the arrival and the first machine, and also between the last machine and the exit point. So basically, since the point that entities enter the system, we need a transfer time till they get to the first machine, and then the second machine, and finally when they leave the system also we need a transfer time till they finally get to the point that they are going to exit the system. And this transfer time is not fixed, it's random and exponentially distributed, and it's 1 minute. So I want you guys, each one of you, to create a new model and build this model, and we are going to submit this in this today's class before we end the class today.
Professor, what should we name the model?
We are in the folder for week 7. So name it as week 7 station and routing module. Example for station and routing module. So save your model in the folder for week 7 and name it at week 7 dash example for station and routing modules. I'm going to create a assignment section on Blackboard so that you guys can upload your model after your. There are 2 people that process part type A, and there's 1 for part B.
Okay, thanks.
So 4 for unwrapping, 2 for type B parts, and 1 for type 2 for type A and 1 for type B. 7 total.
Professor, I have a general question about today's lecture.
Go ahead.
So we were doing the homework, and on assignment, I think, like question 1, there was like the need for delayed like transfer time, and I'm wondering like what's the advantage of using advanced transfer modules versus having a process and just delay the part for like say 5 minutes, and in the process there's also where you can allocate those time to, like I pick transfer, and it seems to have general identical like reports at the end.
Yeah, you can do that too. And even when you define that process time, that transfer time as a process, you have the option that specify the value added time, non-value added time.
Yep.
Let me go back to the model. So here, for example, here you see you can specify as value added time, non-value added time, and one option is transfer time. So
yeah,
if you define it.
Where like I allocate, like I'm wondering if there's an advantage using advanced transfer, like, or we just haven't seen it yet.
This just makes the model and the whole system, the whole calculations a lot easier, especially if you want to send a part directly to another. So for example, if I'm done with processing a part here and I want to then send it to another operation that is located somewhere else in the model. So this just makes it a lot cleaner for you to do this transfer instead of arrows coming from this to all other different modules and so forth. That makes your model complex.
That makes sense. So it's more for like modulating the models into smaller modules.
Yeah. So that makes the job a lot easier, a lot cleaner. And also, as I said at some point, when you want to create animation of your model, and by animation I don't mean the animation that we see when we run the simulation, animations that are created really nicely on top of this model. So let's say if you are a consultant and you're using simulation as your tool, and you want to present your simulation to a customer, you definitely don't want to show them this view and all these boxes and I don't know, arrows and so forth. you want to create a nice animation on top of this model so that it just runs as if it's in the real world. Put an icon for all these actual locations and so forth. If you want to create those nice animations for our simulation models, then we definitely need the stations and routes and so forth. Those definitely are needed for creating those animations. But in just these models, definitely for making the model easier to understand and read, and just less complex picture. But you can definitely capture those transfer times using the processes, and just make sure to specify the type of the process as transfer, so that when you report the results in your report, you see the transfer time, not value added time or non-value added time.
Perfect, thank you. Is there a required way we do problem 1 in this assignment? Do we have to use the advanced transfer module, or
for the whole goal of this assignment is for you guys to get your hand on using the transfer and route module. So this is just for the sake of learning that if you were going to use these modules, how would you use it, where would you put it, and so forth.
Sounds good. Thank you so much.
Sure.
Professor, the minimal until arrival time that I tried that gonna work is 1.4.
1.4, okay.
Yes, that's the lowest, and I tried 1.3 and error will pop up again.
Okay, so 1.4 didn't produce any error for you, for those who are using their personal.
No.
So for all of you guys, you can please change the inter-arrival time to 1.4. At least to make sure all of you are working on the same model and so forth. So for those of you who are using your personal computer, that's fine with me, but I'm just worried that the same situation happens for the exam. If you guys have the option to use the virtual desktop, I would absolutely recommend to do that as well.
Professor?
Go ahead.
Just to confirm, we should have 3 route modules in our entire system. Is that correct?
So 1 to send parts from arrival to the unwrapping, 1 to send them from unwrapping to process part A, and 1 to send it from unwrapping to process part B, and also 1 from the process to the exit, and 1 from processing part B to the exit. So 5, right?
Oh, I meant 5. I'm sorry, I meant 5. Yep.
No worries. That 5 is correct.
Okay.
Make sure I post the videos. I will email you guys when it's done. So make sure to watch the video and do what is needed before we meet in the next class. I do not think that there is a homework for this week, but if there is any, I will share. But with a very, very high chance, there is no homework for this week. Just make sure to practice, guys. Do your homework and make sure you guys are comfortable with the materials we have covered so far.